Hello everyone. Today we are going to look at derivative of general exponential functions y equals b to the power of x. This corresponds to 5.2 in your textbook. On last lesson we looked at derivative of e to the power of x, and today we are going to look at other exponential functions. So base is not e but any other number. Let's remember, for exponential functions the base must be a positive number and it cannot be 1. So if we have f of x equals b to the power of x, derivative of it is going to be b to the power of x times ln of the base. If we have b to the power of g of x, so exponent is not x, but it is a function of x. Then when we take the derivative, we say b to the power of g of x, it is same as original function. Then we multiply this by ln of the base. Then we take the derivative of the exponent and multiply the whole thing by that. So this is a chain rule for derivative of exponential functions. So let's look at some examples here. So find first derivative. So f of x equals 3 to the power of x. So when we take the derivative, let's apply the rule here. So we are going to say 3 to the power of x times, now we need to multiply this by the ln of the base, so ln 3. So we can also write it as ln 3 times 3 to the power of x. Let's look at b. So we have f of x equals 3 to the power of 1 minus 2x. So we are going to take the derivative. So we keep the original function as it is, so 3 to the power of 1 minus 2x. Then we are going to multiply this by the ln of the base. Base is 3, so ln 3. And then we need to take the derivative of the exponent. So derivative of 1 is 0. The derivative of negative 2x is negative 2. So we multiply this whole thing by negative 2. So if we organize this, we get negative 2 times ln 3 times 3 to the power of 1 minus 2x. Make sure you use a bracket here. So this is negative 2 times ln 2 is just a number, and this 3 to the power of 1 minus 2x is multiplied by that. So make sure you use bracket here. Okay, so part C. Now we see a division, x squared divided by 2 to the power of x. Then we need to use the quotient rule here. So derivative of the numerator, 2x, times the denominator, 2 to the power of x, minus derivative of denominator, 2 to the power of x, times ln 2, and we multiply this by the numerator, x squared, divided by square of the denominator. So now we can factor. When we take the derivative, we always leave it in factored form. So we see that x is a common factor and 2 to the power of x is a common factor. So x and 2 to the power of x is a common factor. Then we get 2 from the first term, and then we get x times ln 2 from the second term. So we get x times ln 2, or ln 2 times x, divided by 2 to the power of, so 2 to the power of x to the power of 2, so gives us 2 to the power of 2x. Now we can simplify 2 to the power of x and 2 to the power of 2x. So if we do that, we get 2 to the power of x for denominator. And numerator we have x, 2 times, so let's move the number to the front, so minus ln 2 again in a bracket times x. Okay, next question. It says find the equation of the tangent to y equals 4 times 3 to the power of x at x equals 2. To write the equation of the tangent, first we need to get the slope of the tangent. To get the slope of the tangent, we need to take the derivative of this function. So y prime, 4 is a coefficient, so I keep it. Now I need to take the derivative of 3 to the power of x. So this gives us 3 to the power of x times ln 3. So if I organize this, I get 4 ln 3 times 3 to the power of x. Now to get the slope at x equals 2, let's substitute 2 in the derivative function. So we get 4 ln 3 times 3 square. 3 square is 9. 9 times 4 is 36. So we get 36 ln 3. Okay, so that is the slope of the tangent. So if we write it in mx plus b form, so we get 36 ln 3x plus b. Okay, now to get b for this, we need to substitute a point. We know that x coordinate of the point is 2. We need to get the y coordinate of this point. So we need to substitute 2 in the function. Y equals 4 times 3 square. So that gives us 36. So y coordinate of this point is 36. Now we can sub this point in here to calculate b. So 36 equals 36 ln 3 times 2 plus b. So basically for b you get 36 minus 72 ln 3. So if you write the equation then, we get 36 ln 3x, and b is 36 minus 72 ln 3. So we are just going to leave the answer like this. Most of the time we just need the exact values. So this is this equation in written with the exact values. Last question. You have some word problems in the textbook. So now this is an example for a word problem. At the beginning of year 2000, the population of Indonesia was 221 million. It was growing at approximately 1.5% per year. The equation for this growth is P of t equals 221 in a bracket 1 plus 0.015 to the power of t. As you see, this rate is coming from 1.5 in a decimal as a decimal value, where t is number of years after 2000 and p is the population in millions. So determine the population at 2012. So as you see, for part A, we don't even need to use calculus. So we are just going to calculate the population in 2012. So how many years passed from 2000 to 2012? 12. So we just substitute 12 for t. So 1.015 to the power of 12. Okay. So if we use a calculator, we get 264.2 millions here. Okay. So part B, when is the population will reach 250 million? Again, we don't need to use calculus to answer this question. So this time population is given and we're going to solve for t. 250 millions and 221, 1.015, and again we are looking for t. In advanced functions, to solve such an equation, you would take the log of both sides. But first, of course, you need to isolate the exponential piece from here. So to do that, let's divide both sides by 221. So we get 1.015 to the power of t on the right side. Okay, so again, in the advanced functions, we took the log of both sides. So the base for logarithm was 10. But actually, with the previous lesson, as we learned, we can take now ln of both sides. That will work too, right? So now, if we take ln of both sides, again, when you're taking the log of both sides, you can use any base. Okay. Now I'm going to use the power rule for logarithms, and I'm going to write right side as t times ln 1.015. And left side ln 250 over 221. So to isolate t, let's divide both sides by ln of 1.015. Okay, so then we get t being 8.3 years here. So in 8.3 years, the population will reach 250 millions. So last part, C. What is the instantaneous rate, growth rate at 2005? Now, since it is asking for instantaneous growth rate, we need to take the derivative of the population. Okay, so we keep the coefficient. Now we need to take the derivative of this exponential part. So again, we keep it as it is. Okay, and then we multiply this by the derivative of the base, by the ln of the base, and we need to multiply the whole thing by the derivative of the exponent. But the exponent is t, so derivative of it is 1. Okay, then we get basically 221 times ln 1.015 times 1.015 to the power of t. Okay, and if you want to look at the rate at 2005, so now we need to take the difference between 2000 and 2005. Looks like 5 years passed, so we are going to substitute 5 in the derivative function. Okay, then if you punch everything in your calculator, we end up with 3.545 millions per year. Okay, now you can proceed and do your homework from the textbook, page 240, questions 1 through 9.